Good evening, everyone. A very good evening to all of you, bacho. We are live. We are back on ExamDost. We are back with the rank improvement course on power electronics, lecture number 5. The first lecture of the second unit, that is phase controlled converters, or you can say phase controlled rectifiers. So quickly, everybody join. Come on, everybody. We are about to start the phase controlled rectifiers. जल्दी से सभी लोग आ जाओ. चलिए. Without wasting any time, let me start by first reviewing what we covered yesterday. So yesterday we saw the gate characteristic and the triggering basic. So the gate cathode characteristic is similar to a diode VI curve, and it has the limitation min voltage, max voltage, min current, max current, and the maximum power. Now in the gate triggering circuit, we connect a source in series with a resistance. So resistance will limit the current through the gate. Now what is the load line? Load line is the gate voltage equal to source voltage minus IGRS. And the operating point is the intersection of the load line and gate characteristic curve. For the gate power, if the pulse width is less than 100 microsecond, I use the peak power. For more than 100 microsecond, I use average power. Next beta, we talked about GTO. So GTO is a version of Thyristor which is similar to SCR, but it has an additional property that it can be turned off with the help of a negative gate pulse. Okay. Now, when you talk about GTO, construction-wise, what is different? We have N plus fingers into the anode and the gate region is highly doped. Gate wala region आपका highly doped होता है. So, we need a large negative current to turn off the GTO, because of which the turn off gain is very poor. It is 3 to 5. Okay. That means a significant negative current is required to turn off GTO. In the turn off time, we have storage time, fall time, and the tail time. So if you compare SCR and GTO, to turn off a SCR, we need commutation circuit. GTO can be turned off by negative gate current. Gate current is lower in a SCR, higher in a GTO. Latching current is lower in a SCR, higher in a GTO. Then power rating, SCR has higher power rating than GTO. SCR has slower speed than a GTO. SCR has less cost, higher system cost because of commutation circuit. It is expensive, but overall cost is less because there is no commutation circuit. Now, what are different family members of Thyristor? ASCR with low reverse blocking capability. It is used where high reverse voltage is not encountered. RCT, it has a monolithic integrated SCR and an anti-parallel diode. That is, an anti-parallel diode is integrated on the same IC. It reduces the size of the system and the size of heatsink. Diac, it is a bidirectional trigger device. It does not have a gate. So it will be triggered whenever we exceed the forward and the backward breakover voltage. It is used to trigger the triac. Triac is triode for AC. It is bidirectional, bipolar, fully controlled. SOA is all 4 quadrant. So it is similar to two anti-parallel SCR with a common gate. It is used in AC voltage regulator and solid state relay. That means a semiconductor switch. Now the firing circuit, in a resistance firing circuit, the limitation is alpha is less than equal to 90 degree. R1 resistance limits the gate current, R2 resistance limits the gate voltage, and R is a resistance which we vary to vary the firing angle. But the problem is power dissipation is large. In RC firing circuit, we use a capacitor to shift the gate pulse and generate firing angle above 90 degree. Okay. But the best is the UJT relaxation oscillator. It generates very sharp pulses. Now, in this case, there is an intrinsic standoff ratio, that is RB2 by RB1 plus RB2, and it is approximately 0.7 to 0.9. And the UJT turns on whenever the voltage at emitter exceeds the eta VBB plus VD. So whenever voltage exceeds this level, then UJT turns on. And whenever the UJT turns on, the capacitor of the oscillator discharges through UJT and provides a pulse to the thyristor. So capacitor will charge via RC circuit, and once UJT is on, the capacitor will discharge, providing the pulse to the SCR. So the time period is RC ln 1 upon 1 minus eta. Now, when you connect diode with a pure inductor, the diode never turns off. The current is given by Vm by omega L 1 minus cos omega t. This is average and RMS. When you connect it to a pure capacitor, the diode conducts till 90 degree. After 90 degree, the current tries to reverse, so my diode turns off. So diode will charge the capacitor up to the peak voltage just like a clamper, after which diode remains off. When you connect it to a LC oscillator, the diode conducts for a half cycle because current follows the equation of sine omega t. So after pi, the sine omega t tries to reverse, and that is when the diode turns off. So the final capacitor voltage is 2 Vs minus V0, where Vs is the supply voltage, V0 is the initial capacitor voltage. Okay? बोलो भाई, if there is any doubt in whatever we have covered so far, ये मैंने कल वाला आप लोगों को फटाफट तरीके से रिव्यू करा दिया है. कोई अगर डाउट है जितना हमने अभी तक कवर किया है, बिकॉज आफ्टर दैट आई विल स्टार्ट विद द नेक्स्ट यूनिट. रेडी हैं सभी लोग? स्टार्ट करें. स्टार्ट करें भाई अपना डिस्कशन. तैयार सभी लोग? So my objective of the day is to teach you half wave rectifier. Okay, single phase half wave rectifier is my objective to teach you today. But remember, beta, try to understand each and everything very carefully, very clearly, so that you can understand the basics of the rectifier. बेसिक आपको यहीं पे समझ आने वाले हैं, इसीलिए बेसिक के लिए बहुत सतर्क रहेंगे, बहुत ध्यान से एक एक चीज पे फोकस करेंगे. चलिए, so first let me teach you the basic terms of a rectifier. The first term is called as the form factor. It is basically seen on the DC side or the output side of rectifier. It is the ratio of output RMS voltage to the average voltage. Now form factor is always greater than 1. Okay, form factor is always greater than equal to 1, but the closer the form factor goes to 1, the better is the waveform, or the waveform becomes close to unit DC. ठीक है, फॉर्म फैक्टर जितना 1 के नजदीक जाएगा, वेवफॉर्म उतनी ही बेहतर DC बनेगी, बट फॉर्म फैक्टर जनरली 1 से बड़ा होता है. नाउ व्हाट इज द वोल्टेज रिपल फैक्टर? Ripple factor tells you the AC content in the waveform or the harmonic content in the waveform divided by the average value. So basically, beta, on the DC side of the rectifier, we desire a constant or an average output. So all other harmonics, it may be fundamental, second harmonic, third harmonic, all other harmonics are undesirable. है ना, आउटपुट पे सिर्फ क्या चाहिए? डीसी चाहिए, बाकी सभी हार्मोनिक अनडिजायरेबल हैं. तो इन द न्यूमरेटर आई एम टेकिंग आरएमएस ऑफ द हार्मोनिक डिवाइडेड बाय एवरेज. So it is under root form factor square minus 1. So for ideal DC, form factor is 1 and ripple factor is 0. Ripple factor is 0. एक्वा भाई, इस चैनल पे मेरे नेटवर्क के लेक्चर पड़े हुए हैं, तो सेकंड ऑर्डर सर्किट में मैंने एलसी ऑसिलेटर पढ़ा रखा है, उसको एक बार देख लेना. बाकी कल के लेक्चर में भी मैंने आपको एलसी ऑसिलेटर का जो है ना इक्वेशन लिखने का तरीका बताया था डायरेक्ट, कि अगर मान लो आपको दो इक्वेशन लिखनी है, IL और VC. अगर IL में इनिशियल वैल्यू दे रखी है तो उस इनिशियल वैल्यू के साथ cos ओमेगा t ले लेना. अगर VC में इनिशियल वैल्यू दी है तो उसके साथ cos ओमेगा t ले लेना. ठीक. सेकंड चीज, अगर किसी का भी स्टेडी स्टेट वैल्यू नॉन जीरो आ रहा है, स्टेडी स्टेट कैसे निकालेंगे? इंडक्टर को शॉर्ट करके कैपेसिटर को ओपन करके. अगर स्टेडी स्टेट वैल्यू नॉन जीरो आ रहा है तो उसके साथ 1 माइनस कॉस लगाएंगे. अगर इनिशियल वैल्यू भी जीरो और स्टेडी स्टेट भी जीरो तो उस पैरामीटर के साथ साइन लगाते हैं. बस इतना है। और वोल्टेज को करंट में कन्वर्ट करने के लिए सर्ज इंपेडेंस से डिवाइड करना, यानी रूट एल बाय सी से, और करंट से वोल्टेज जाने के लिए रूट एल बाय सी से मल्टीप्लाई करना। बस इस तरह से डायरेक्ट इक्वेशन लिख सकते हो। पीडीएफ बेटा फ्री डाउनलोड्स में ऐप पे अवेलेबल है। एक बार फ्री डाउनलोड्स में जाओगे, आगे की चीजें सेल्फ एक्सप्लेनेटरी हैं, समझ जाओगे। ठीक है, कि उसके अंदर यूट्यूब लेक्चर पीडीएफ होगा, ये लेक्चर आप यूट्यूब पे देख रहे हो। उसके अंदर जाओगे यूट्यूब लेक्चर पीडीएफ के, तो उसके अंदर पूछेगा गेट या एजेई, ऑब्वियसली गेट का लेक्चर है। उसके बाद पूछेगा भैया कॉम्प्रिहेंसिव का पीडीएफ चाहिए या क्रैश का, तो क्या अटेंड कर रहे हो, क्रैश कोर्स। उसके अंदर जाओगे, सब्जेक्ट पूछेगा पावर इलेक्ट्रॉनिक्स, खत्म बात। चल, next we talk about the parameters on the AC side of the rectifier. The first parameter is the distortion factor. Now what happens is beta, whenever we talk about rectifier actually produces voltage harmonics on DC side and current harmonics on AC side. तो बेटा होता क्या है रेक्टिफायर में, that the AC side is supplied by a sinusoidal voltage source, but because the output current is not sinusoidal, the input current is not sinusoidal. तो क्या होता है, basically V in is sinusoidal, but the input current depends on the load current and input current is non-sinusoidal. Input current sinusoidal नहीं आता, तो basically it contains harmonics. Now what is desirable? It is desirable that input should only be sinusoidal. The input current should be sinusoidal. So I in, the only desirable term is the fundamental. I in का जो desirable term होता है fundamental होता है, ठीक है। तो now बेटा distortion factor is the fundamental RMS current by total RMS. That means total RMS माने it contains all the harmonics. But what is desirable? The desirable is the fundamental RMS. So fundamental is one component of the total current. That is why this factor is less than 1. The closer it goes to 1, it means fundamental is dominating the overall current. So your current is near to a perfect AC. समझे? जितना G1 के नजदीक जाएगा उतना एक तरह से फंडामेंटल आपका डोमिनेट कर रहा है और आपका करंट साइनोसोइडल बन रहा है। बेटा गेट 27 का नेक्स्ट बैच आपका दिसंबर में स्टार्ट होगा, उसके बारे में जल्दी इंफॉर्मेशन दूं। नेक्स्ट इज द टोटल हार्मोनिक डिस्टॉर्शन। टोटल हार्मोनिक डिस्टॉर्शन माने आरएमएस वैल्यू ऑफ ऑल द हार्मोनिक्स डिवाइडेड बाय आरएमएस ऑफ फंडामेंटल। द फॉर्मूला इज अंडर रूट 1 by g square minus 1. Then rectification efficiency. It means beta at the output of the rectifier, how much power is contributed by the DC or the average. So DC or the average power is V average I average divided by total power available at the output. It means whatever is the total output power that I obtain, how much part of that is contributed by DC. टोटल आउटपुट पावर का कितना हिस्सा डीसी कंट्रीब्यूट कर रही है। नेक्स्ट इज द ट्रांसफॉर्मर यूटिलाइजेशन फैक्टर बेटा। इट मींस हाउ मच रेटिंग ऑफ ट्रांसफॉर्मर is getting converted to the useful power. Now the desirable power in a rectifier is the power contributed by DC. Desirable power वो है जो DC contribute करती है, that is V average I average. Now you are dividing by supply RMS voltage and current. In rectification efficiency you have output RMS voltage and current. Here you have supply RMS voltage and current. So basically you are comparing the kVA rating of the transformer to the DC power at the output. Now, where is the transformer located? Transformer is actually located, beta, at the input of the rectifier. So the AC input to the rectifier is being supplied by a transformer. Now, beta, displacement factor is the cos of angle between the voltage, supply voltage, and the fundamental current. So supply voltage is sinusoidal, I told you, but current is non-sinusoidal. So when you write the equation of the fundamental component of current, you observe the phase shift between V and I. So cos of that is the fundamental displacement factor. आप करंट का फंडामेंटल कंपोनेंट लिखते हैं और V और I1 के बीच का फेज शिफ्ट चेक करते हैं. नेक्स्ट, इनपुट पावर फैक्टर इज रियल पावर बाय VS RMS IS RMS. आप कहोगे सर ये तो TUF जैसा दिख रहा है. You are right, but it is slightly different because this power is the total power available at the output. ये P क्या है? ये सिर्फ DC कंपोनेंट का पावर नहीं है, ये टोटल रियल पावर है जो आउटपुट पे आती है. फॉर आर लोड इट इज IRMS स्क्वायर इनटू R. फॉर हाईली इंडक्टिव लोड वेयर I0 is constant, highly inductive load where I0 is constant, it is V average into I0. Now remember the first lecture of this course, what did I tell you? To calculate the power, use the RMS current or voltage if it is a resistance. But if either voltage or current is constant, use the average value of the other parameter. अगर V और I में से कुछ भी constant है तो दूसरे वाले का average लेते हैं. So for highly inductive load, I0 is constant, therefore I am taking average value of V0. This formula becomes G into FDF. This is FDF and this is G if the input voltage is sinusoidal. Then PIV is the maximum reverse voltage across a device. That is, whenever I have a switch like a diode or a SCR, what is the peak negative voltage across that? That is called as the PIV. उसको क्या बोलेंगे बेटा? उसको बोलेंगे PIV. चमका ये सभी लोगों को? जल्दी से मुझे बताइए. Is this clear to everyone? यहां पे किसी को कोई डाउट है तो बोलिए. V0 H RMS is VS RMS minus VS1 RMS. नहीं बेटा, ऐसा नहीं होता है. Whenever you want to remove the fundamental RMS, it will be removed like under root VS RMS square minus VS1 RMS square. क्योंकि क्या होता है बेटा, जब अलग अलग हार्मोनिक की RMS ऐड करते हैं राजेंद्र, तो अलग अलग हार्मोनिक की RMS ऐसे ऐड नहीं होती A प्लस B प्लस C. वो कैसे ऐड होती हैं? अंडर रूट A स्क्वायर प्लस B स्क्वायर प्लस C स्क्वायर. तो अगर आपको रूट ऑफ B स्क्वायर प्लस C स्क्वायर निकालना है तो आप करेंगे रूट ऑफ टोटल स्क्वायर माइनस A स्क्वायर. पॉइंट समझ में आया? RMS cannot be directly added for different harmonics. RMS are added like root A square plus B square plus C square. That is why harmonic RMS is under root of total RMS square minus fundamental RMS square. Okay बेटा? Is this clear to everyone? समझ में आया सभी लोगों को? चलिए, तो one by one we will move to the half wave rectifier. First I will talk about uncontrolled rectifier. Uncontrolled माने I am taking the help of a diode for rectification and the load I am taking as a pure resistor. Load के नाम पे मेरे पास एक resistance है, हाँ, पीक इनवर्स वोल्टेज PIV. तो लोड के नाम पे मेरे पास एक रेजिस्टेंस है और रेक्टिफिकेशन के लिए आई एम मेकिंग यूज ऑफ अ डायोड. नाउ दिस इज अ वेरी सिंपल सर्किट. व्हेन आई एम टेकिंग अ साइनोसॉइडल इनपुट ड्यूरिंग द पॉजिटिव हाफ साइकिल, डायोड विल बी ऑन, so output will be same as the input. During negative half cycle, diode will be off, because of which current will be zero. If current is zero, the V0 will be zero. अगर current zero आया तो V0 will be zero. So see this, what is happening beta? The input voltage is sinusoidal, but during the positive half cycle, नहीं बेटा, THD और VRF अलग अलग है. PhD के टाइम पे आपने बोला हार्मोनिक आरएमएस बाय फंडामेंटल आरएमएस, और VRF में बोला हार्मोनिक आरएमएस बाय DC वैल्यू। तो यानी जब आप VRF की बात कर रहे थे, आप आउटपुट पे देख रहे थे, वहां डिजायरेबल था एवरेज। ओके, यू वर लुकिंग एट द आउटपुट वेयर डिजायरेबल कंपोनेंट वाज एवरेज, so you were dividing harmonic RMS with the average voltage. But on the AC side, the desirable component is the fundamental component. So we are dividing harmonic RMS by fundamental RMS. So देखिए, during the positive half cycle, the output is a copy of the input. During the negative half cycle, my output is 0. Again, during positive half cycle, output is same as input. Now current in a R load, ठीक है, current in a R load बेटा, it is simply I naught equal to V naught by R. If I naught is V naught by R, so the shape remains the same. ठीक है, the shape remains the same, but height changes. Same shape, but height meaning amplitude changes. Okay. Now when I talk about the diode voltage, now beta, when diode is conducting, it is short circuit, voltage is 0. But when the diode is off, the difference of the supply and the output is the diode voltage. But actually beta, when diode is off, output is 0. So the supply voltage appears across diode. तो जब डायोड ऑन था तो शॉर्ट सर्किट था, but when it is off, it is following the supply voltage. It is following the supply voltage. So it is reverse bias. Now you can see the maximum negative voltage is minus Vm. So PIV is written as Vm. PIV is written as Vm. ठीक है, ये बात समझ में आ गई? So what did we learn about R load? For R load, we learnt that V naught cannot become negative because then I naught will be negative and diode does not allow negative current. समझे? So that is what we learn about a R load. That output voltage cannot go into the negative region. Output voltage नीचे नहीं जा सकती, सिर्फ पॉजिटिव आ सकती है. Secondly, V naught I naught have the same shape. So V naught can never become negative, otherwise I naught will be negative. Diode does not allow negative current. Now what is the average voltage? The period is 2 pi beta. If you see, the period of the waveform is 2 pi. But the sine curve we are getting from 0 to pi. So area I am taking from 0 to pi. So average is Vm by pi. Similarly, when you are taking RMS, what is the procedure? 1 upon period. We have to take area from 0 to pi. But what area? Area of square. Then everything under root. So total time period 1 by 2 pi. 0 से पाई तक का इंटीग्रेशन और एरिया स्क्वायर का लिया जाता है. So this comes out as Vm by 2. But there is a shortcut beta. RMS value of sine is Vm by root 2. Correct? But this is half sine. Half value is sine. Half value is 0. So the duration of the waveform is pi. The total period is 2 pi under root. So you will get Vm by 2. तो यहां पे मैंने क्या किया? This is RMS of sine wave. This is my duration. And the denominator is the period. So I have scaled the RMS. तो इस तरह से shortcut लगा सकते हो to find RMS. Now RMS by average is the form factor pi by 2. Voltage ripple factor is root form factor square minus 1. It is 1.21. So this factor beta greater than 1, it tells you that the AC or the harmonic content is more than DC. यहाँ पे harmonic DC को dominate कर रहे हैं, which is very bad. Now because it is a resistance, real power is RMS square by R. Real power RMS से निकलेगी अगर resistance है. Rectification efficiency. To find the efficiency, we divide the power contributed by average or DC and the total power. So the average component contributes a power V average square by R, whereas RMS contributes a power V RMS square by R. So it is average by RMS square or 1 by form factor square. तो एवरेज कंपोनेंट कितनी पावर देगा? वी एवरेज स्क्वायर बाय आर, और टोटल पावर है वी आर एम एस स्क्वायर बाय आर. ओके बेटा, so that is about your R load. Now when you introduce a inductor, what is so special about inductor? Inductor opposes the change of current and inductor has to charge and discharge. Now resistance does not charge and discharge, but inductor does charge and discharge. Because of this requirement beta, my current and voltage do not stop at pi angle. Current और voltage pi पे रुकते नहीं हैं. They extend beyond pi. वो pi के आगे जाते हैं. Why they go beyond pi? Because inductor takes time to discharge. Inductor को समय लगता है discharge होने में. So that is why conduction does not stop at pi. It continues after pi. You remember yesterday beta I taught you a case when diode was connected to a pure inductor and I told you that conduction happens for 2 pi. Conduction does not stop. It continuously continues up to 2 pi. So beta, when there is inductor, you do not say, sir, during the negative half cycle, the device will be reverse biased and conduction will stop. So yesterday I gave you a golden rule. In case of power electronics, whenever there is an inductor, you see the current. Whenever the current becomes zero and current tries to reverse, then only the device turns off. आपको मैंने बोला था पावर इलेक्ट्रॉनिक्स में जब टर्न ऑफ देखना है डिवाइस का, कभी भी आप वोल्टेज से नहीं देखेंगे. आप नहीं बोलेंगे कि नेगेटिव हाफ साइकिल है तो सर ऑफ हो गया. आप करंट देखेंगे. करंट अगर जीरो जाता है और उल्टा फ्लो करने की कोशिश करे तभी डिवाइस बंद हो सकती है. So that is why beta I am saying conduction will continue until the inductor fully discharges. So I will get beta, I will get the extinction angle. ठीक है, I will get the extinction angle from 0 to beta, where beta is the extinction angle. Conduction goes from 0 to beta, where beta is more than pi. What is beta? Beta is the extinction angle at which current becomes 0 or current extincts. Current extinct हो गया माने 0 हो गया. Now beta, this beta you cannot determine. They have to give you in the question, because practically to derive beta you have to use the AC transient approach, and then also it will be derived using numerical technique like Newton-Raphson. ठीक है, न्यूटन-राफसन जैसी टेक्निक आपको लगानी पड़ेगी. देखो आज के लेक्चर में आपको कोई भी फॉर्मूला याद नहीं करना है. ठीक है, मैं लेक्चर बाय लेक्चर बताऊंगा. यू डोंट हैव टू रिमेंबर एनी फॉर्मूला टुडे. यू हैव टू अंडरस्टैंड द वर्किंग. इफ यू अंडरस्टैंड द वर्किंग, यू नीड नॉट इवन ड्रॉ द ग्राफ. Like you can understand for a R load, conduction will be up to pi, and then you can directly derive these quantities like average RMS. है ना? If you know that it will conduct up to pi, because after pi V is negative, I will be negative, diode will be off. These sort of basics you have to understand. So see, in case of RL load, if you see the waveform extends even after pi. So waveform is extending after pi, okay, up to beta. So the current waveform, how is it? current gradually increases, reaches a peak value, then decreases. The maximum of the current occurs. I naught maximum, I naught peak occurs at omega t equal to pi by 2 plus theta, where theta is tan inverse omega L by R. Pi. Okay. Now, when you talk about the diode, till the time diode is on from 0 up to beta, the diode voltage will be 0. It will be short circuit. After beta, it will follow the supply voltage. So when diode is off, it will follow the supply voltage, and when diode is on, the voltage will be 0. Understood, beta? So now, while computing the average, I will integrate from 0 to beta. Okay? I will integrate from 0 to beta while computing average, because I understand that conduction continues beyond pi. तो मैं 0 से बीटा तक इंटीग्रेट करूंगा, where beta is more than pi due to inductor. So what do you understand here? That inductor increases the extinction angle. Now this is the average output voltage by integration. Average current is V average by R. What is the point here? How you are writing this? For average or DC, inductor is short circuit. So average current is average voltage by resistance. Now when you take RMS, you integrate 0 to beta square of the voltage. So this is RMS. But remember beta, I naught RMS is not equal to V naught RMS by R. Because when you talk about RMS considers all harmonics. And for harmonics or AC, L is not short circuit. इंडक्टर शॉर्ट सर्किट नहीं होता AC के लिए. That is why you cannot say that I naught RMS is V naught RMS by R. Now beta, if you see, I have taken beta less than 3 pi by 2. So I can say the PIV will be VM. The maximum negative voltage will be VM. Is that clear beta? ये सभी को समझ में आया यहां तक? बताओ जल्दी से. क्लियर हुआ? आपको एक एक लोड पे सर्किट कैसे बिहेव करेगा ये सीखना है हाफ वेव रेक्टिफायर में. Because in half wave rectifier beta, they may twist the question, they may create a new problem, and for tackling new problem your basic should be strong, not the formula. यहां फॉर्मूला मैटर नहीं करता है, मैटर करते हैं आपके बेसिक. तो एक एक लोड की नियत समझिए, एक एक लोड का बिहेवियर समझिए. नेक्स्ट, if you connect a anti-parallel diode, this anti-parallel diode is called freewheeling diode. Why? Because beta, whenever this diode is on, whenever the diode is on, the load current can freely flow like this. The load current can freely circulate. So that is why it is known as a freewheeling diode. Now if you see beta, it is connected in a opposite direction. That means polarity of V naught and the polarity of freewheeling diode is opposite. Which means if V naught is negative, V naught negative का मतलब है if V naught reverses the polarity, then this freewheeling diode will be on. Then this freewheeling diode will be on. मेरी बात समझ रहे हो? अगर V naught की पोलैरिटी उल्टी कर दें तब ये डायोड फॉरवर्ड बायस हो जाएगा और ये डायोड कंडक्शन करना स्टार्ट कर देगा. So now if you see in the RL load beta, from pi to beta, V naught was becoming negative, and that is where your freewheeling diode will start to conduct. So it will start to conduct after pi when it will become forward bias. Pi के बाद conduction चालू करेगा जब ये forward bias हो जाता है. Now see this region beta. In this region current is positive but voltage is negative, है ना? If you see this region मेरे बच्चों, in this region, if you see carefully, in this region pi to beta, current is positive, voltage is negative, which means the power is negative. In this region, I naught positive, V naught negative, therefore power is negative. Therefore, power is returned to supply. पावर को हम सप्लाई को वापस भेज दे रहे हैं. Okay, we are returning the power to the supply. That means beta, when inductor is discharging, it returns some of the power to the supply. But now beta, when freewheeling diode will be on after pi, current will circulate in this loop. It cannot reach the supply. So inductor does not return the stored energy to the supply, because of which it will now take more time to discharge. देखिए पहले क्या हो रहा था, पाई से बीटा तक पावर नेगेटिव थी. नेगेटिव पावर माने पावर उल्टी जा रही है, तो इंडक्टर के पास जो स्टोर्ड एनर्जी थी वो सप्लाई को लौटा रहा था. लेकिन अब जब फ्रीव्हीलिंग डायोड चालू हो गया तो इंडक्टर का करंट सप्लाई तक पहुंचेगा ही नहीं, ये लूप में घूमता रहेगा, तो इंडक्टर की एनर्जी इंडक्टर वापस नहीं कर रहा. इसी वजह से उसकी डिस्चार्जिंग का एक ही रास्ता बचा कि उसकी एनर्जी रेजिस्टेंस में खपे. अब अगर सिर्फ रेजिस्टेंस में खपत होगी तो ज्यादा टाइम लगेगा डिस्चार्जिंग में, यानी बीटा इंक्रीजेस और इट इंप्रूव्स द कंटिन्यूटी ऑफ द करंट. कंटिन्यूटी इंप्रूव करने का मतलब क्या है, कोशिश कर रहा है करंट बंद ही ना हो कभी. ठीक है, तो ड्यू टू फ्रीव्हीलिंग डायोड, इंडक्टर टेक्स more time to discharge, so beta increases, load current continuity improves. Okay, continuity of the load current will improve. Is that clear to everybody? So earlier inductor was releasing the stored energy in two forms, dissipating as the heat through R and returning the energy to the supply. इंडक्टर की एनर्जी दो जगह खप रही थी, सप्लाई में भी जा रही थी और आर में भी. नाउ इट विल ओनली डिस्चार्ज वाया आर. ओके, तो नाउ बेटा this diode will conduct only up to pi. ये डायोड सिर्फ पाई तक कंडक्ट करेगा. After pi, when V naught is negative, freewheeling diode will conduct and current will circulate in the loop. So if you see beta, this was the case for a RL load. This was the case for a RL load. But what will happen when you have a RL plus freewheeling diode? What will happen with RL plus freewheeling diode? Basically, this part of the waveform will be removed. Okay. So diode will conduct from 0 to pi. Okay. And V naught will also be between 0 and pi. Okay. And current will be between 0 and beta. So during this time from pi to beta, freewheeling diode will conduct. pi से बीटा freewheeling diode conduct करेगा. Now this waveform is same as the R load. This waveform is same as the R load. Now that is why average RMS will be same as R load. So earlier during pi to beta, inductor energy goes into resistance and source. Now pi to beta, inductor energy is only dissipated in R because freewheeling diode is on. So inductor takes more time to discharge. समझे? पहले पाई से बीटा तक इंडक्टर का करंट जो था वो किस में जा रहा था? रेजिस्टेंस और सोर्स दोनों में. अब सिर्फ आर में. फ्रीव्हीलिंग डायोड का करंट बनाना है तो आउटपुट करंट का इतना हिस्सा बना लो. तो बेसिकली if you copy this much part of current, that is D1 current. If you copy this part of current, it is freewheeling diode current. करंट के दो हिस्से कर लो. 0 से पाई वाला जो ग्राफ है that will be the current through the main diode. पाई से बीटा वाला जो ग्राफ है that is the current through the freewheeling diode. Okay. Now next is the RE type of a load. It is called as a battery charging load. Now beta, whenever there is a source of EMF in the load, the diode does not immediately become forward bias in the positive half cycle. It will only become forward bias when supply is more than E. ये सीधा ऐसा नहीं कह सकते 0 के बाद पॉजिटिव हाफ साइकिल आई भाई साहब ऑन हो गए. नहीं, सप्लाई को E से ज्यादा होना पड़ेगा. then only current can circulate in the closed loop. एवरेज आरएमएस वैसे देखो इस सब में निकलवाया नहीं जाता करंट का सुमुखा जी. ठीक है, क्यों नहीं निकलवाया जाता वो भी मैं आपको बता दूं, क्योंकि करंट की वेवफॉर्म बहुत इररेगुलर होती है. ठीक है, और बाकी तो हम लोग पीवाईक्यू भी देखेंगे, बट ऐसा सवाल देखो आज तक आया नहीं. पूछने के लिए पूछा कुछ भी जा सकता है, बट जैसा मैंने बोला बेसिक याद रखेंगे तो आप निकाल लेंगे कुछ भी. नाउ लिसन, Vm sin omega t will be greater than E, then only diode conducts. So I find the intersection of the supply and the EMF. So I write Vm sin omega t equal to E. This gives me omega t equal to theta sin inverse E by Vm, and also pi minus theta. Why? Because sin theta and sin pi minus theta are always same. Sin theta और sin pi minus theta बराबर होते हैं, तो इंटरसेक्शन दो पॉइंट पे मिलेगा, थीटा और पाई माइनस थीटा. हाउ डज इंडक्टर कंटिन्यू टू प्रोवाइड द करंट इफ द डायोड इज रिवर्स बायस? कुलदीप भाई मैंने यही बोला, रिवर्स बायसिंग तो तब आएगी ना जब कोई डिवाइस बंद होगी. आप सप्लाई वोल्टेज देख के ये कैसे कह सकते हो रिवर्स बायस है? रिवर्स बायस के लिए आपको डिवाइस का वोल्टेज देखना होगा, सिर्फ सप्लाई का नहीं. आपने तो ये कह दिया कि सर नेगेटिव सप्लाई हो गई तो रिवर्स हो गया. कैसे? सप्लाई नेगेटिव हुई है ना, डायोड का वोल्टेज तो नेगेटिव नहीं हुआ. सिर्फ एनोड वोल्टेज देख के, बिना कोई कैथोड वोल्टेज देखे, हाउ कैन यू से डिवाइस इज रिवर्स बायस? सपोज द एनोड वोल्टेज इज -5 बट कैथोड इज -10, स्टिल इट विल बी फॉरवर्ड बायस. आर यू गेटिंग माई पॉइंट? So just by looking at voltage at the supply, you cannot tell when the device will be forward or reverse. So when you are turning on the device, check the voltage. But when you are turning off the device, always check the current. Okay? यही तो आपको अपना thought process change करना है. I0 RMS नहीं निकाल पाएंगे रोशन भाई RL लोड के लिए, because waveform is not regular. Now listen. From theta up to pi minus theta, my diode is forward bias, and in RE load, it is always better to approach via current. पहले मैं waveform दिखाता हूँ. देखिए, when you see this is the line that is E, so E is intersecting the supply voltage at 2 points, theta and pi minus theta. So in this region, beta, supply is more than E, so diode will be on. So you can say the extinction angle will be pi minus theta. Conduction angle is the duration for which the device conducts, that is final minus initial. Final angle minus initial angle. Now, when you talk about the output voltage, okay, when you talk about the output voltage will be same as supply when the diode is on. So V naught will be equal to Vs, which is Vm sin omega t when diode is on, and it will be equal to E when diode is off. Because when diode is off, beta, current will be zero. If current is zero, the resistance voltage is zero. So output is equal to E. अगर डायोड बंद हो गया, करंट जीरो, तो आर का वोल्टेज जीरो, तो वी नॉट आएगा ई. दैट इज वाई बेटा वेन एवर डायोड इज ऑफ यू आर गेटिंग ई. नाउ व्हाट इज करंट? करंट इज सिंपली वी नॉट माइनस ई बाय आर. So to draw the current, beta, shift this waveform downwards by E and then divide by R. पहले जो V0 का ग्राफ है इसे नीचे सरका लेना. कितना? E. So it will be centered around the time axis and then divide it by R. Now when diode is off, what is the diode voltage? Supply minus output. Output is actually equal to E, Vm sin omega t minus E. So what will I do is, this pink curve, the supply curve, I will shift it downwards by E. So maximum negative will become minus Vm minus E. मैंने क्या किया, ये जो पिंक वाला ग्राफ था इसको E नीचे सरका दिया, तो मेरे को पीक वैल्यू मिल गई माइनस Vm माइनस E. बात समझे? I have shifted the pink curve downwards by E. So now we know that current will only flow between theta and pi minus theta, and the value will be V naught is Vm sin omega t, Vm sin omega t minus E by R. So that is how we calculate the average, and this parameter is important in a RE load. RE load में जो पूछा जाता है ना, that is average charging current. Why? Because significance of average current is related to the charge, and this circuit is basically charging a battery. So average current is important because average current is responsible for charging. For RMS, same expression. Just take the square of the function inside the integration and put a square root outside. इंटीग्रल के अंदर वाले फंक्शन का स्क्वायर कर देना, बाहर रूट लगा देना. Now to find the power delivered to the battery, it will be E into I average, and power in the resistance will be I RMS square into R. तो बैटरी में E I average और resistance में I RMS square into R. Okay. Clear beta? Next is the last type of load, that is the RLE type of load, or you can say DC motor load. Okay, DC motor load. Now again, if you observe, you have added a inductor in a RE load. So earlier my beta was pi minus theta. Now conduction will extend beyond pi minus theta. इंडक्टर आता है तो कंडक्शन को लंबा खींचता है. So now beta, my conduction goes up to beta, which is above pi minus theta. ठीक है, मेरा जो बीटा है that will be above pi minus theta. Okay, so now beta, the current waveform because of inductor, gradually it is increasing then decreasing. इंडक्टर आता है तो वेवफॉर्म ऐसी इरेगुलर हो जाती है ना, धीरे धीरे बढ़ता है फिर गिरता है. एंड डायोड वोल्टेज इज सेम, Vs minus E और Vm sin omega t minus E, but you will trace that curve from beta. अब आप उस ग्राफ को बीटा से ट्रेस करोगे, ना कि पाई माइनस थीटा से. यानी जो आपको ग्रीन वाला कर्व दिख रहा है ना, ये तो सेम ही है, बट आपने इसको ट्रेस शुरू कहां से किया? बीटा से, व्हेन योर डायोड टर्न्ड ऑफ. ठीक है, तो व्हेन डायोड इज ऑफ, द वोल्टेज ऑफ डायोड is Vm sin omega t minus E. Now still you can calculate the average current very easily beta, very easily, because Because when you are talking about average current, you can directly take the R, because in average inductor does not appear. So same as a RL load, sorry, RE load, but upper limit is beta. ठीक है? Same function as RE load, but upper limit is equal to beta. Okay, just a moment. Okay, now inductor does not appear in average, है ना, because inductor is shorted for average. That is why beta V average is E plus IR. Inductor is not there. Now for RMS, you cannot calculate RMS directly because you cannot ignore the inductance. But you can calculate VRMS from theta up to beta. It will be the supply voltage. From beta up to next cycle 2 pi plus theta, it will be E. थीटा से बीटा तक डायोड ऑन है तो सप्लाई को फॉलो किया, और बीटा से अगली बार तक किसको फॉलो करेगा? ई को. तो थीटा टू बीटा सप्लाई, बीटा टू 2 पाई प्लस थीटा, वी नॉट इज ई. ठीक है, तो आप यहां पे वी नॉट आरएमएस तो निकाल सकते हो, बट नॉट आई नॉट आरएमएस. एंड व्हाट अबाउट पीआईवी सर? पीआईवी बेटा, इफ बीटा इज मोर देन 270, अगर बीटा 270 डिग्री के आगे गया, यानी ये वाला पॉइंट देखो यहां पे आ रहा है ना Vm प्लस ई. बट इफ दिस ग्राफ डिड नॉट स्टार्ट बिफोर 270, rather this graph started after 270 like this, so the peak negative voltage will appear here बीटा पे. आप समझ रहे हो ना? देखो 270 के पहले स्टार्ट हुआ तो मैक्सिमम नेगेटिव ऑकर्स एट 270, बट इफ इट स्टार्टेड आफ्टर 270 तो मैक्सिमम विल ऑकर व्हेन इट इज एट बीटा, तब बीटा पे ही मैक्सिमम आएगा. तो विदाउट ई Vm साइन बीटा, विद ई Vm साइन बीटा प्लस ई. लॉजिक समझ में आया? अगर बीटा आपका 270 के पहले है तो मैक्सिमम नेगेटिव 270 पे दिखता है, और यही पॉइंट अगर आगे शिफ्ट कर दोगे तो मैक्सिमम नेगेटिव बीटा पे दिखेगा. देन यू विल गेट मैक्सिमम नेगेटिव एट बीटा. ठीक है, समझ गए? एल छूटा नहीं है. इंडक्टिव लोड तो कल करा दिया था ना, प्योरली इंडक्टिव लोड कराया तो था कल. डायोड कनेक्टेड टू प्योर इंडक्टर. चलो नेक्स्ट आई विल स्टार्ट विद द कंट्रोल्ड रेक्टिफायर. नाउ इंस्टेड ऑफ अ डायोड आई एम यूजिंग SCR. Now, what is so different about SCR? SCR gets forward biased in the same way as a diode. SCR की forward biasing diode की तरह होती है, but SCR will only conduct when it receives the gate pulse, a firing pulse. So it does not conduct immediately after forward biasing. It will conduct after an angle alpha. ठीक है, so it will always conduct after an angle alpha. So now when diode was there, diode conducted in the complete positive half cycle 0 to pi, but SCR will conduct from alpha to pi. Why not beyond alpha? Sorry, beyond pi. Beta, beyond pi, V0 will be negative, I0 will be negative, and SCR is a unidirectional switch. It does not allow negative current. समझे? पाई के बाद V0 I0 दोनों नेगेटिव होते हैं और SCR नेगेटिव करंट अलाउ नहीं करता. तो देखिए, we are providing the firing pulse at alpha. So from alpha to pi beta, we are tracing the, from alpha to pi, we are tracing the input voltage. Okay, from alpha to pi. Before alpha, the voltage, output voltage is 0, and after pi also the output is 0. I0 has the same waveform as V0. It is a resistive load. So I naught has same waveform as V naught. That is what we understood in case of R load. Now when thyristor is on, the thyristor voltage is 0, and when my thyristor is off, the voltage is same as the supply. ऑफ होगा तो ओपन सर्किट हो जाएगा ना, तो सारा वोल्टेज थायरिस्टर पे आ जाएगा. नाउ बेटा, so from 0 to alpha it is off. From 0 to alpha it is off. It is waiting for the firing pulse. So even though the voltage is positive, it is not conducting. That is forward blocking. तो भले ही सप्लाई वोल्टेज पॉजिटिव है, लेकिन ये बिना फायरिंग पल्स के कंडक्ट नहीं करेगा, तो इसे कहेंगे फॉरवर्ड ब्लॉकिंग. एंड व्हेन द वोल्टेज इज नेगेटिव, इट इज कॉल्ड एज रिवर्स ब्लॉकिंग. So it is reverse bias for an angle pi. The time for which a SCR is reverse bias in a circuit is called circuit turn off time. कितनी समय के लिए एक SCR सर्किट में रिवर्स बायस है, वो सर्किट टर्न ऑफ टाइम है. I know the angle is pi, so time will be pi by omega. How to derive this? First check the angle of second forward biasing. Second forward biasing माने SCR gets forward biased during the positive cycle at 0. Next time it will be forward bias at 2 pi. I'm not saying when does it conduct. I'm just saying second forward biasing. मैं कह रहा हूं forward bias कब हुआ दूसरी बार, ये देखो. कंडक्शन नहीं कह रहा हूं. Forward bias at 0, next time forward bias at 2 pi, and the conduction stops at pi. So take the second angle as beta. So angle of second forward biasing minus beta by omega. Always remember, angle of second forward biasing minus beta by omega is circuit turn off time. सिंगल फेज RLE लोड विद फ्री व्हीलिंग डायोड लेंगे तो I नॉट का वेवफॉर्म चेंज हो जाएगा. नहीं, चेंज कहां हुआ था? RL विद फ्री व्हीलिंग डायोड में भी बस बीटा बढ़ता है, वेवफॉर्म थोड़ी शेप थोड़ी चेंज होता है सुमुखा जी. बाय अप्लाइंग अ फ्री व्हीलिंग डायोड द करंट शेप डज नॉट चेंज, ओनली थिंग इज बीटा इंक्रीजेस स्लाइटली, नथिंग मोर नथिंग लेस. और बेटा मैं दोनों ही लैंग्वेज में समझा रहा हूं महेश. आई एम एक्सप्लेनिंग इन बोथ द लैंग्वेज. आई कांट यूज मोर इंग्लिश देन दैट. ओके, I'm trying to explain in both the languages. Most of the content is in English, but wherever I need to explain a point in detail, I use both the languages. Okay? चलिए. Now, beta, conduction is happening from alpha to pi. So, while taking the average 1 upon 2 pi, 2 pi is the total cycle. Integration from alpha to pi. Integration from alpha to pi. So, this is the average. I average will be V average by R. For RMS, take the square of the function inside integration. Integrate from alpha to pi, take square root outside. So this is my RMS. And I RMS is V RMS by R. There is no inductor, no problem. Now, when you talk about rectification efficiency, it is V average, I average upon V naught RMS, I naught RMS. Now, I average is V naught by R, I naught RMS, V naught RMS by R. So, basically, R will be cancelled. This will become V average square upon V RMS square. So, it is 1 by form factor square. So, in R load, na beta, the rectification efficiency is 1 by form factor square. Now, TUF is V average, I average by supply RMS voltage, supply RMS current. I average is V average upon R. Supply RMS current is same as the load RMS because source delivers current to load. लोड में वही करंट जा रहा है जो सप्लाई से आ रहा है. तो सप्लाई का RMS करंट और लोड का RMS करंट बराबर है. ओके, so now R will be cancelled. It will be V naught square by VSR V naught R. What about the input power factor? Output power in a resistor V RMS square by R divided by apparent power at the input, VSR, ISR. So now ISR will be V naught R by R. ISR is same as I naught R, V naught R by R. So you get simply output RMS by supply RMS. For R load beta, the simple method of power factor is V naught RMS by VS RMS. Next beta, if I talk about purely inductive load. So yesterday, what did I tell you about purely inductive load? That in an inductor, the average value of voltage is 0, because of which the area under V naught should be 0. And that is called as the volt second balance. Now SCR becomes forward biased at at 0. But it does not conduct until alpha, the time at which it receives the firing pulse. SCR फॉरवर्ड बायस 0 पे हो गया, लेकिन कंडक्शन मेरे भाई अल्फा पे चालू करेगा जब इसको गेट पल्स मिलता है. Now from alpha to pi, the supply is positive, so inductor will charge. Whenever the inductor voltage is positive, remember inductor charges, because beta voltage of inductor is L di by dt. So when VL is positive, di by dt is positive, so current increases. When VL is negative, di by dt is negative, so current decreases. So from alpha to pi, it will charge. Now the area under V naught should be 0, so it should discharge for same duration. It is charging for pi minus alpha. For next pi minus alpha, it should discharge. That is from pi up to 2 pi minus alpha. अगर पाई माइनस अल्फा एंगल की चार्जिंग है तो उतने ही एंगल पे डिस्चार्जिंग होनी चाहिए. तो पाई के बाद पाई माइनस अल्फा और लोगे तो यू विल रीच 2 पाई माइनस अल्फा. तो दिस इज बीटा. नाउ कंडक्शन एंगल इज द फाइनल एंगल माइनस इनिशियल, दैट इज 2 टाइम्स पाई माइनस अल्फा. तो कंडक्शन एंगल इज ऑलवेज बीटा माइनस अल्फा, फाइनल माइनस स्टार्ट. तो इफ यू सी बेटा, from alpha to pi, voltage is positive, inductor is charging. From pi up to 2 pi minus alpha, inductor is discharging. So now if you see mere bachcho, you can clearly see that area is coming out to be 0. Okay. The area is coming out to be 0. Okay, this area is 0. So from alpha to pi, charging current increases, pi to 2 pi minus alpha, discharging decreases. Okay. So now what you can say, you can derive that from alpha up to this, V naught is Vs, Vm sin omega t. So L di by dt is Vm sin omega t. So just like yesterday beta, di will be Vm by omega L. I am multiplying and dividing by omega. So now because conduction starts at alpha, I will say that at alpha, current is 0. At omega t, current is I. Integration of sign will be minus cos. Whenever you see minus beta in the integration, always first put the lower limit, then upper limit. Now directly you cannot say the constant is DC, the sinusoidal is AC. Average and RMS current have to be computed by integration. This is the current function. ठीक है, एवरेज और आरएमएस आपको इंटीग्रेट करके निकालना होगा. Now thyristor gets turned off at 2 pi minus alpha and second forward biasing happens at 2 pi. So it gets turned off at 2 pi minus alpha, second time forward bias at 2 pi. So circuit turn off time is 2 pi minus 2 pi minus alpha by omega. So it is alpha by omega. ठीक है, सो सर्किट टर्न ऑफ टाइम विल बी अल्फा बाय ओमेगा. क्लियर हुआ भाई यहां तक? बताइए जल्दी से, इज दिस क्लियर टू एवरीबडी? बोलो मेरे भाई, फटाफट बताओ. ओके, सो फॉर एवरेज इफ यू वांट you have to go like this. Okay, for RMS, one by 2 pi like this. Take the square and then take root outside the integration. And PIV will be VM sin alpha. Okay, PIV will be VM sin alpha. Okay. क्लियर भाई सभी को यहां तक? बोलो जल्दी से, सभी को क्लियर है? Now I will go to the RL load. Now beta, in the R load conduction goes up to pi. When we are introducing an inductor, what will inductor do? Inductor increases the extinction angle. So conduction will continue after pi. Conduction will continue after pi. देखो भाई, वेवफॉर्म याद नहीं रखी जाती, बनाना सीखा जा सकता है. ठीक है, इतनी वेवफॉर्म रटी नहीं जा सकती. So beta will go above pi. Now, if you see, now you will start at alpha, but you will continue up to pi. Sorry, you will continue up to beta, which is beyond pi. तो आपने सप्लाई के ग्राफ को ही फॉलो किया, लेकिन अल्फा से शुरू करके बीटा तक, जहां बीटा पाई के आगे था. Now, because of inductor, current gradually increases, then decreases. Okay. So this current is derived using AC transient. What about thyristor voltage? When thyristor is on, voltage is 0. But when it is off, it follows the supply voltage. Now what is the circuit turn off time beta? Second forward biasing at 2 pi. Conduction stops at beta. So second forward biasing minus beta by omega. PIV will occur as VM. ठीक है, PIV will be VM. What about the average output? Just integrate the sine curve from alpha to beta and divide by the period, that is 2 pi. So 1 by 2 pi alpha to beta sine omega t. I average will be V average by R because inductor is shorted for average. But I RMS is not equal to V RMS by R. And what about V naught RMS? One by 2 pi. Take the integration of the square. Okay. तो देखो, अगर आप बेसिक समझ जाते हो ना, what will every load do, then it becomes very easy actually. Beta minus alpha plus half sine 2 alpha minus sine 2 beta. So that is your RMS, but I naught RMS is not equal to V naught RMS by R. Sir, done revision this chapter but did not start problems. भाई रिवीजन कैसे हो गया बिना प्रॉब्लम के? रिवीजन का हिस्सा होता है प्रॉब्लम सॉल्विंग. Okay, next is a freewheeling diode. What will freewheeling diode do? It will cut the negative portion. So after pi, when V naught becomes negative, freewheeling diode will turn on. So it will start conducting from pi up to beta. Other than that, what else will freewheeling diode do? It will also increase the value of beta because inductor takes more time to discharge. Now inductor energy is only getting dissipated in the resistor, not in the supply. Okay? So slow discharging, hence beta increases. So now if you see, diode only conducts up to pi. From pi up to beta, freewheeling diode will be on. So this part of I naught comes from the freewheeling diode and this part of I naught comes from the main thyristor. ठीक है, यहाँ पे thyristor आएगा, डायोड नहीं. This part of current will come from thyristor. Peak value of current still is at the same time pi by 2 plus 5. Peak current उतने पे आता है. Now beta, average value will be same as the R load because this graph is same as R load. So Vm by 2 pi 1 plus cos alpha. पढ़ाने दो. V naught average is 1 by 2 pi. You can integrate from alpha to pi. Vm sin omega t d omega t. And I average will be V average by R. What about circuit turn off time? The thyristor stopped conducting at pi. Second forward biasing comes at 2 pi. पाई पे रुक गया था थायरिस्टर, वहां से फ्रीव्हीलिंग डायोड आ गया और कंडक्शन या फिर अगला फॉरवर्ड बायसिंग आएगा 2 पाई पे एंड PIV इज VM. ओके, नेक्स्ट इज अ RE टाइप ऑफ लोड. व्हाट हैपेंस इन RE? The thyristor becomes forward biased just like a diode at theta, but it cannot start conducting as soon as it becomes forward biased. So it will start to conduct at alpha, which is greater than theta. So the conduction will happen from alpha up to pi minus theta rather than theta to pi minus theta. But what if alpha is less than theta? What if I provide the firing pulse before forward biasing? Okay, before forward biasing, then beta, the thyristor will conduct. As soon as it becomes forward bias, it will start to behave like a diode. So it will start to conduct at theta. अगर आपने फॉरवर्ड बायसिंग के पहले ही गेट पल्स प्रोवाइड कर दी, तो अब वो जैसे ही फॉरवर्ड बायस होगा बेटा, तुरंत वो कंडक्शन चालू कर देगा जैसे डायोड होता है. ओके, नाउ I average, you will integrate from alpha to pi minus theta, Vm sin omega t minus E by R. I told you already, always approach RE load via current. ठीक है, RE load में करंट डिराइव करने पे फोकस कीजिए. तो कंडक्शन इज फ्रॉम अल्फा टू पाई माइनस थीटा. द आउटपुट करंट इज V minus E by R. Okay, and then V average, if you want V average, it is E plus I average into R. So that way you can get V naught average. What about RMS? Take the square of the function inside and take square root outside. Why is RMS current needed? To find power in the resistor R, average current for power in the battery. So if you see beta, this dotted line is E. आयरा हम काट देंगे. So now this is my E. So now beta, the point of intersection is theta and pi minus theta. But if you see, I am starting the waveform after theta. This is theta. I am starting after theta. That is alpha. So I will follow the supply voltage from alpha up to pi minus theta. And after that, once the thyristor is off, the output will be equal to E. अल्फा से पाई माइनस थीटा सप्लाई फॉलो किया, फिर E आएगा. Now current is V naught minus E by R. So shift the waveform downwards by E and then divide by R. पहले V naught के ग्राफ को E नीचे शिफ्ट करो, फिर R से डिवाइड करो. Now when thyristor is off, the thyristor voltage is supply minus output, that is supply minus E. So we will shift this supply voltage graph downwards by E. ये जो डॉटेड ग्राफ है सप्लाई का है, इसे E नीचे शिफ्ट करो एंड ट्रेस इट फ्रॉम द एंगल पाई माइनस थीटा अप टू 2 पाई प्लस अल्फा. आप इसे कहां से कहां तक ट्रेस करेंगे? पाई माइनस थीटा से 2 पाई प्लस अल्फा तक. नाउ हाउ टू फाइंड द सर्किट टर्न ऑफ टाइम? For the first time, thyristor becomes forward bias at theta. For the next time, it will become forward bias at 2 pi plus theta. And it stopped conducting at pi minus theta. Theta is pi minus theta. So 2 pi plus theta minus pi minus theta by omega. Minus pi minus theta by omega. Last is RLE load. Because of inductor, the conduction goes above pi minus theta. So beta is greater than pi minus theta. So now I am starting again at alpha, which is after theta. But I will continue up to beta, whereas this angle is pi minus theta. So मैं beta तक गया. After beta, the thyristor is off. Thyristor is off. Whenever thyristor is off, V naught will be E. So now to find I average, the conduction is from alpha to beta, Pm sin omega t minus E by R, and then V naught average is E plus I average into R. Okay, but you cannot calculate I RMS. I naught RMS cannot be computed. तो आप देखिए बेटा, what is most important in all these derivations? The angle of conduction. The angle of conduction. That is, when does the conduction start and when does the conduction end? Conduction कब चालू होके कब खत्म होता है, यही सबसे ज्यादा जरूरी है. And if beta is less than 3 pi by 2, then PIV is Vm plus E. If beta is greater than 3 pi by 2, PIV. Because if you go above 3 pi by 2 na, you cannot see the peak as Vm. आप Vm वाली peak नहीं देख पाओगे. Now all these are the formulas that we have covered today. ठीक है, बाकी मैंने आपको बता ही दिया है. चलिए, कम टू डेली क्विज बेटा. समझ में आ गया ना? बेसिक के साथ टिके रहिए. हाफ वेव रेक्टिफायर में, हाफ वेव रेक्टिफायर में बेसिक से ज्यादा जरूरी कुछ भी नहीं है. नथिंग इज मोर इंपॉर्टेंट देन बेसिक. हाँ, बीटा पाई माइनस थीटा से पाई के बीच भी हो सकता है. बस क्लैरिटी के लिए मैं पाई के आगे लेता हूं ताकि वेवफॉर्म साफ दिखे. In a single phase half wave rectifier with a RL load and a freewheeling diode, how does V naught average compare to the case with just a R load? RL plus freewheeling diode and R load. Compare the average output. बोलिए, compare करिए इनके average को. It is same because V naught waveform does not become negative in both the cases. V नॉट की वेव फॉर्म दोनों ही केसेस में नेगेटिव नहीं जाती. नेक्स्ट, for a single phase half wave controlled rectifier supplying a highly inductive load, load current is constant. What is RMS current rating of the thyristor? यार यहाँ पे ना अनकंट्रोल्ड होना चाहिए और यहाँ पे डायोड होना चाहिए. तो देखिए क्या होगा. इफ I नॉट इज कांस्टेंट, ठीक है, 0 to pi, diode will be on. बट अगर ऐसा ही माने तो बेसिकली it essentially says SCR never turns off. So thyristor current is equal to I naught. So RMS will be I naught. Because if the load current is constant, beta, if the load current is constant, that is only possible in a half wave rectifier if the switch never turns off. अगर स्विच कभी बंद नहीं होगा तभी करंट कांस्टेंट आएगा. चलिए ट्राई द नेक्स्ट वन, PIV ऑफ द डायोड. Now what is the PIV beta? VM. PIV is equal to VM. चलिए next. Output current of a single phase full bridge rectifier is perfectly smooth. Fundamental component of input current is given. What is the displacement factor? If this is the fundamental component of the source current, what is the displacement factor? Cos phi 1. A single phase full converter is operating with alpha equal to 120 and highly inductive load. This is beta actually na full wave rectifier. So full wave rectifier with alpha less than 90 is rectifier. Okay. So this is not, we have not covered it yet. We will cover this tomorrow. Next, THD of the input current for a single phase fully controlled converter with continuous load current. What is distortion factor? ये भी यार full converter का ही है. Distortion factor is 0.9. ठीक है, ये भी full converter का है. Next, for single phase half wave rectifier with RLE load, conduction is from theta up to beta, where theta is sine inverse E by Vm. What is the PIV? Assuming it turns off at beta. What is PIV? बताइए. For a load with a source of EMF, what is PIV? एक ऐसा लोड जिसमें EMF भी है, PIV कितना आता है? बोलिए. In general, it is taken as Vm plus C. ये वाला कब लेना है? इसमें भी ना मॉड लगाओगे तब ले सकते हो. But if nothing is mentioned, you just write Vm plus C. अगर कुछ भी नहीं दिया तो आप सिर्फ लिखिए Vm प्लस ई, एज्यूमिंग बीटा इज लेस देन 270. Which statements are true regarding performance of single phase half wave uncontrolled rectifier? Form factor is pi by 2. For a resistive load, we derived this. TUF is low. That is a drawback of half wave rectifier. TUF is low. Rectification efficiency for RL load is higher compared to R load. No, because average decreases in RL load beta because of the negative portion of V0. Average decreases. Addition of freewheeling diode prevents output from going negative. Yes, freewheeling diode does not allow the output voltage to become negative. समझे? So average decreases, so efficiency decreases. Chalo, next. A single phase full converter feeds the RLE load. Under which condition will it operate in continuous conduction mode? RLE लोड में कंटिन्यूअस कंडक्शन किस कंडीशन में मिलेगा? ये भी लेकिन फुल कन्वर्टर का ही है बेटा. इंडक्टेंस इज वेरी लार्ज, बीटा मोर देन पाई प्लस अल्फा. ठीक है, अल्फा ग्रेटर देन 90 से कोई लेना देना नहीं है, बीटा ग्रेटर देन पाई प्लस अल्फा. क्या क्या कह रहे हो? बी ऑप्शन रिपीट. बेटा TUF क्या होता है? हाफ वेव रेक्टिफायर का खराब होता है, यानी कि योर KVA रेटिंग इज नॉट प्रॉपरली यूटिलाइज्ड. व्हाई इज दैट? because there are lots of harmonics, so the contribution of the DC component or the average component to the power is low, so TUF is low. TUF काफी लो आता है क्योंकि एवरेज का कंट्रीब्यूशन बहुत कम है. और सिंगल फेज सेमी कन्वर्टर ये भी ब्रिज वाला है बेटा, with a highly inductive load which will be the different fully controlled bridge converter for same firing angle. एवरेज डिफरेंट आता है, इनपुट पावर फैक्टर डिफरेंट आता है, डिस्प्लेसमेंट डिफरेंट आता है, सब कुछ ही अलग आता है फुल और सेमी में. ये भी आगे का सवाल है, आने दो. चलिए, कम टू द क्लासरूम क्वेश्चंस बेटा. आई एम फीडिंग अ रेजिस्टिव लोड फ्रॉम अ सिंगल फेज AC supply through a step up transformer and a diode. The turn ratio is 2. You need to tell me the KVA rating of the transformer. Now listen to me very carefully. Now what is the secondary voltage? It is 230 into 2 because it is step up transformer, 460 volt. What is V0 RMS based on diode? It is Vm by 2. It is a half wave rectifier. It is simply Vm by 2. What is I0 RMS? Because it is a resistive load. Now, power at the secondary. आप देखो सेकेंडरी से निकालो पावर या प्राइमरी से क्या फर्क पड़ता है. 460 है ना. ट्रांसफॉर्मर हैज इक्वल पावर ऑन बोथ द साइड्स, so I'm calculating on secondary because my entire rectifier is on secondary side. 2.493 kVA. ठीक है, that is VSR ISR. So supply RMS current in a half wave rectifier is same as the output RMS. सप्लाई और आउटपुट का RMS सेम होता है. Now try this. This is a purely inductive load. What will be the reading of moving iron voltmeter M1 and M2? I want the reading of the moving iron voltmeter. What does a moving iron instrument read? RMS value. Moving iron always reads RMS value. So basically I need the RMS voltage across diode and inductor. बताइए. This is a purely inductive load. So diode is always on short circuit. So M1 will read 0. And output will be same as supply. Zero and 141.4. ठीक है, 0 और 200/√2. बड़ा सिंपल क्वेश्चन है. RMS value of a half wave rectified symmetric square wave is 2 ampere. Symmetric square wave of 2 ampere. RMS वैल्यू बताना है. सिमेट्रिक स्क्वायर वेव है, 2 एम्पियर का उसका एम्पलीट्यूड है, उसका RMS बताइए. उसको अगर हाफ वेव रेक्टिफाई कर दिया जाए. ओके, यू हैव टू टेल मी द RMS. You are doing half wave rectification of a symmetric square wave. What is symmetric square wave? Where the height above and below the time axis is same. So this is the square wave. Okay. Now what we will do is, we will do half wave rectification. In half wave rectification, what will happen? The negative value will become 0. So this is 2. So RMS. How to take RMS of a flat waveform? Take the height square root duration by period. So it is √2. Height into under root duration by total period. That is √2. Chalo next. Half wave diode rectifier is connected to a RE load. What is the PIV? Very easy. If a half wave diode rectifier is connected to RE load, what is the PIV of diode? Come on, bachcho. What is the PIV of diode? PM plus E 400. Very good, beta. Very good, Subhadeep. Shadan 400. Next, देखिए. This is a question based on the source inductance. Now, because you guys are revising power electronics, I expect you guys to answer. This is a question based on source inductance. What will be the conduction angle of D1 and D2? देखो, ideally तो they should conduct for 180 degree. D1 should conduct from 0 to 180. and D2 should conduct from 180 to 360 to maintain constant I naught. But due to source inductance, what will happen? Due to source inductance, what is going to happen? Both conduct for more than 180, which is actually 180 plus mu, which is the overlap angle. ठीक है, दोनों का जो कंडक्शन है वो 180 के ऊपर जाता है क्योंकि दोनों ओवरलैप भी करते हैं. चलिए, ट्राई दिस. Voltage across the SCR when the current decays to 0. Let me explain, beta. The current decays to 0 at beta. So it is asking the SCR voltage at beta. SCR का करंट 0 जाता है बीटा पे, तो बीटा पे आपसे वोल्टेज मांग रहा है. बताइए, बनाइए जल्दी से इसको. आया भैया आंसर? देखो बहुत इजी है. तो करंट बिकम 0 at omega t equal to beta. When current is 0, V naught becomes equal to E. So thyristor voltage will be supply minus output तो दिस इज थायरिस्टर वोल्टेज. समझ गए? बिकॉज व्हेन करंट इज 0, वोल्टेज आउटपुट इज E. ये देखो बड़ा बढ़िया क्वेश्चन है. A half wave thyristor converter supplies purely inductive load. If alpha is 120, what is beta? If alpha is 120, what is beta? तो बीटा विल बी 240. देखिए, till 180 degree voltage positive, current increases for 60 degree. For next 60 degree voltage will be negative, current will decrease. If it charges for 60 degree, it should discharge for 60 degree. Therefore, beta is 240. चलिए next level 2 पे आते हैं. Now, beta, thyristor is fired in every positive half cycle. Peak instantaneous output is 230. What is alpha? Peak instantaneous output माने the peak of the waveform of V naught is 230. It is a resistive load. If the peak of the V naught is 230, then what is alpha? ये मैं ना आपको ड्रॉ करके समझाता हूं. देखो बेटा, there are two possibilities. Listen to me very carefully. We know that in a resistive load, conduction takes place till pi. Conduction takes place till pi. But there are two possibilities that this angle is 90. First is if alpha is less than pi by 2. Is alpha below 90. So it will conduct like this. Okay, up to pi. Second is if alpha is greater than pi by 2. Till it conducts up to pi. In our load, it does not go above pi. Now, beta, in the first case, if you see, the peak voltage is Vm. And in the second case, if you see, the peak voltage occurs at alpha, Vm sin alpha. Now, beta, peak, that is Vm, is 230 root 2. ठीक है? But the peak of output is only 230. V naught peak is 230 and not Vm. Therefore, this is a valid case. क्योंकि अल्फा अगर 90 से कम होता तो पीक तो Vm आता. Now 230 is Vm sin alpha. Sin alpha will be 1 by root 2. Now there are two possibilities, 45 and 135. I will choose the second one because alpha should be greater than 90. ठीक है? तो आंसर इज बी. लॉजिक समझ में आया? If you start before 90 degree, the peak is Vm. If you start after 90, peak is Vm sin alpha. चलिए next. Find the battery charging current, which means the average current of the circuit. Find the average current. करिए इसको. आया भाई आंसर? सी आ रहा है? देखो, दिस इज अ SCR, but SCR is fired continuously. Whenever you see a statement like this, that SCR is fired continuously, it starts to act like a diode. Now we know the conduction is from theta up to pi minus theta, where theta is sine inverse E by Vm. 120 upon 220 root 2. Always remember, the by default the voltage given in AC is RMS. बाय डिफॉल्ट जो AC वोल्टेज होती है वो RMS ही होती है, ठीक है। नाउ I एवरेज Em sin omega t, okay. This is the condition of the current. Now integration of sine will be minus cos. This is I average. Now beta, whenever you use angle outside sine and cosine, what is R? R is 10. What is Vm? 220 root 2. Cos 22.68 minus 120. Now what I was saying is, whenever you use angle outside sine and cosine, convert them to radian. So I am converting degree to radian. You are getting C. Okay? इस type से. So such kind of question on RE load can be asked. Find the reading of the ammeter if it is of MC type. MC माने moving coil. If the reading is 13.46 for moving iron. I am giving you the reading of moving iron. I need the reading of moving coil. This is a diode with a purely inductive load. Now average so this is for moving coil, this is for moving iron. Therefore average is C. ठीक है, आंसर इज C. Next, a diode circuit feeds ideal inductor assuming initial inductor current is 0. Switch is closed at 2.5 millisecond after positive zero crossing of source voltage. Peak inductor current is 20. What is inductor? Now let me tell you, in pure inductor, voltage is L di by dt. So when current is maximum, di by dt is 0. Therefore voltage is 0. So peak current occurs when voltage is 0 and voltage or di by dt goes from positive to negative. This is the concept of maxima, beta. If the derivative goes from positive to negative, maxima occurs. अगर डेरिवेटिव प्लस से माइनस जाए तो मैक्सिमा आएगा. And this happens at pi. So it is telling you that the maximum current is 20 at angle pi. समझे? पीक करंट कहां आएगा? जहां वोल्टेज प्लस से माइनस जाए प्योर इंडक्टर में. देखो, I will convert it to angle. Now, the conduction starts at pi by 4 and maximum occurs at pi. So integration of current is from 0 to 20. Initial current is given as 0, peak is 20, and angle of conduction from pi by 4 up to pi. करंट 0 से 20 जा रहा है और कंडक्शन लूंगा पाई बाय 4 से पाई तक. ठीक है, 20. इंटीग्रेशन ऑफ साइन इज माइनस कॉस. L will be Vm. Vm is 200 root 2. Omega. Omega is 2 pi f. 20. 1 plus 1 by root. So 200 into root 2 plus 1 divided by 2000 pi. 76.8 millihenry. Okay, 76.8 millihenry. समझे? जो टाइम दिया है ना स्विच क्लोज करने का, वहां से कंडक्शन स्टार्ट होगा. तो कंडक्शन विल स्टार्ट एट 2.5 millisecond. Now see this. This is a LE type of a load. Now listen to me very carefully. ये वाला मैं सॉल्व करता हूं. So in wherever you have a inductor beta, sorry, wherever you have a EMF, you first calculate theta, because theta is the angle when the conduction starts. थीटा ही वो एंगल है जहां से कंडक्शन आपका चालू होता है. 27.46. Now beta, what is inductor voltage? Vs minus E. This will happen from theta up to pi minus theta. Inductor charges. Yes. After pi minus theta negative, so inductor discharges. So inductor charges up to pi minus theta, after which it will discharge. पाई माइनस थीटा तक चार्ज होने के बाद डिस्चार्ज होगा. तो मैक्सिमम करंट ऑकर्स एट पाई माइनस थीटा. ठीक है, इट विल ऑकर एट पाई माइनस थीटा. लॉजिक समझे? बढ़ता जा रहा है पाई माइनस थीटा तक, फिर गिर रहा है. तो मैक्सिमम ऑकर्स एट पाई माइनस थीटा. नाउ एल डी आई बाई डी टी is Vm sin omega t minus e. So di now beta current increases from 0 to maximum. At theta current starts, at pi minus theta it is maximum. I max one by 100 pi. What is L? L is 10 millihenry. Pm 230 root 2 cos 27.46 minus 150 180 minus 2 into 27.46 into pi by 180. Okay. लॉजिक क्लियर हुआ? बताइए भाई. इज द लॉजिक क्लियर टू एवरीबडी? $79.5. Okay. चलो. This question is similar to what we have solved. So this is your homework. Power in the battery will be E into I average. अभी निकाला था ना हमने एवरेज वाला क्वेश्चन. SCR को कॉन्टिन्यूसली फायर भी किया था. मैं एक काम करता हूं, मैं आपको इसका आंसर दे देता हूं. नाउ द आंसर विल बी करंट इज 5.42 एम्पियर. ठीक है, चलो. So come to the assignment. A GTO can be turned off by negative pulse at the gate. GTO को ऑफ करने के लिए नेगेटिव पल्स लगाते हैं. For our firing circuit, maximum voltage is 100. We want to limit the current to 2 ampere. So basically current should be less than equal to 2. So 100 by R. So R should be greater than equal to 50 ohm. D option. SCR having a turn on time of 5 microsecond, latching current 50 milliampere and holding current 40 is triggered by a short duration pulse, minimum pulse width. So see, this current will be 100 by 5, 20 milliampere. What about this current? So I1 will be beta current of a RL circuit. Okay. Now what I want is the thyristor current should be equal to the latching current for SCR to turn on. During turn on, do not worry about the holding current. So it is the sum of the two current, 20 plus 5. Now tau will be L by R, 0.5 by 20, 0.025 second. तो 30 मिली एम्पियर तो e to the power minus t by tau is 0.994. So what is time? One 150.4 microsecond. ठीक है, आंसर विल बी 150.4 microsecond. SCR has a gate cathode characteristic that is a straight line. Okay. So we saw this type of question already. Now PG equal to VGIG 0.5. 130 IG square is 0.5. So what is IG? Point 0.6201 ampere. What about VG? 8.0622. Now what is RS? ES minus VG by IG. Based on the load line, I am writing 111.9 ohm. A option. ठीक है. For a SCR, EGI characteristic is given as 7.5 plus 1.8 IG. Gate voltage consists of rectangular pulse of 10 volt and 75 microsecond duration. Value of R1 to limit the peak power dissipation of 2 watt. Now beta, this width is less than 100 microsecond. So use peak gate power. Now मेरे बच्चों VGIG is 2. Now VG is 7.85 plus 1.8 IG. So this is a quadratic equation beta which you can solve. 1.8 IG square 7.5 IG minus 2. So IG is 0.2515. So when I know IG is 0.2515, what is VG? $7.9527. Now, what is R1? It is the ES minus VG by IG. The supply voltage is 10. So, beta, basically there is no role of this duty cycle. कोई role नहीं है duty cycle का. Sir, how can it be used? It will be used in the numerical where the pulse width will be more than 100. If it is more than 100, I will use the average power. Now peak power is 2 watt. Average power will be duty cycle into peak power. That is how. Average power dissipation in the gate. One watt. PG average is duty cycle 0.5 into 2. Okay. चलो ये लेवल 2 वाला मैं आपको कल कराता हूं. ठीक है, आज ऑलरेडी वी आर ओवर टाइम. ये लेवल 2 वाला असाइनमेंट कल डिस्कस करेंगे. ठीक है, बाकी का असाइनमेंट आज वाला और जो कल का बच गया वी विल डिस्कस टुमारो. तो टुमारो वी विल हैव द क्लास एट द सेम टाइम. चलिए, तो थैंक यू एवरीवन, हैव अ ग्रेट डे एवरीबॉडी. और कल फिर मिलेंगे. वी विल कंटिन्यू आवर स्टडी ऑफ रेक्टिफायर्स. और देखो YouTube वाले बच्चों के लिए मैं बता दूं बेटा, राइट नाउ वी हैव लॉन्च द न्यू रिकॉर्डेड बैचेस ऑन विच फ्लैट 30% डिस्काउंट इज रनिंग, EB30. और अगर आपको हमारे RIB का हिस्सा बनना है तो देयर इज अ 70% डिस्काउंट यूजिंग द कोड YT70. आप हमारे RIB का हिस्सा बन सकते हो. कितने सब्जेक्ट कंप्लीटेड है उन्हें रिकॉर्डेड देख सकते हो, आने वाले सब्जेक्ट को आप लाइव अटेंड कर पाओगे। आपको लाइव सेक्शन में जाना है और उम्मीद या उन्नति बेस्ड ऑन योर ब्रांच चूज करना है एंड जस्ट यूज द कोड YT70। चलिए, थैंक यू एवरीवन।